Hello all. In this session, we will be learning how to draw the isometric projection of a hexagonal prism. So whenever you get a question like this, you have to first identify what type of solid it is. So here it is a prism and the base will be hexagonal in shape. It is given as 30 mm base edge and axis is 70 mm long and it is resting on one of its rectangular face. So you have to identify whether the solid is vertical with respect to the axis or horizontal. In this case, the question can be either the axis is horizontal or it can be stated as it is resting on a rectangular face. It will be having 6 rectangular faces and it will be resting on any one of them. Now, when you are considering the isometric projection, you can see that the rectangular faces or one of the rectangular face will be on the base and the laminas containing the hexagonal shape will be vertical. So in the earlier video, we have seen how to draw a rectangular lamina. In this case, this solid can be assumed to be made up of 6 rectangular laminas and 2 hexagonal laminas. Now in this position, when it is resting on a rectangular face, you can see that these hexagonal laminas will be vertical in shape. But as per the rules of the isometric projection, we have only two conditions. All the horizontal edges should be drawn as lines inclined at 30 degrees to the base and all vertical edges should be drawn as vertical lines. But in this case, there are various edges inclined at different angles. So whenever you get a question on solids whose faces are other than a square or a rectangle, you have to first draw the orthographic view in isometric scale if it is a question of isometric projection. Then you have to inscribe that figure or inscribe that orthographic view inside the smallest possible rectangle or a square. So in this case, we will be first drawing a hexagon. Then we have to inscribe that hexagon inside a rectangle. Then we will be drawing the isometric projection corresponding to this rectangle. Then we'll plot the points A, B, C, D, E, F, which are the corners of the hexagon inside that rhombus. Rhombus in the sense the isometric view of the rectangle. So since the question is on isometric projection, we have to first construct the isoscale. So the construction is detailed in the previous video. So I'll elaborate it again. First draw a horizontal line, then a line inclined at 30 degrees, then another line inclined at 45 degrees. Then OB will give the line indicating the isometric length, which is at 30 degrees, and OC will give, or OC is meant for plotting the true length, which is at an angle of 45 degrees to the base. Then you plot a point at a distance of 30 mm from O. Then if you draw a vertical line from these points, so the dimensions are 30 and 70. I have plotted 30 and 70 on the line OC, which is at which angle of 45 degrees to the base. Then I have dropped verticals from these 2 points to the line OB. Then the distance from O to these points will give the isometric length. Now I will be constructing a hexagon with iso length of 30 as the side. So remember, you have to construct the orthographic view in the isometric scale itself. Why? Because we will be plotting the points from that orthographic view. Now, how we should draw this hexagon? In the question is specified that the hexagon is lying on one of its rectangular faces. So when you are drawing the orthographic view, make sure that one of the base edges is in the XY line. So I have drawn the hexagon like this. So I will be labeling it as A, B, C, D, E, and F. Now I've drawn BC specifically like that, or not a corner on the base, since we have to make the solid rest on one of its rectangular faces. Now as a condition, we have only constructions where horizontal and vertical lines can be used. So I'm going to inscribe this inside as small as possible rectangle. So I've drawn a rectangle and I'm naming it as 1, 2, 3 and 4. So the next step is I'm going to draw the isometric projection corresponding to this rectangle 1, 2, 3, 4. So this rectangle indicates both the sides. That is, we will be having when this is resting on its rectangular face, we'll have two hexagonal faces vertically, one at the front and one at the back. So these two will have the same figure. So we can plot them using this single figure. So whenever you are getting a question on this, the first step is to draw the orthographic view according to isoscale and then inscribe them inside the smallest possible rectangle. Now we will go with the construction of the isometric projection of this rectangular lamina. So we will first create a skeleton, and this is not the actual view. So you have to draw using very thin lines. Use 2H pencils for this. So first I am drawing the baseline. Then I will pivot this at a point 3. You should imagine that this lamina is vertical. So vertical in the sense 2, 3 and 1, 4 will be horizontal. So they have to be drawn as third degree inclined line. Whereas 2, 1 and 3, 4 they will be vertical itself. So I am first pivoting at the point 3 since it is at the leftmost end. Then I am drawing the vertical at 3, 4 whose length is exactly equal to this length which we have taken from the orthographic view. So you can draw a line and take a compass and cut this distance. Then you have to draw 2, 3 at an angle of 30 degrees to the base. So I am drawing 2, 3 which will be inclined 30 degrees. Then I'll complete the other two sides. Another vertical line indicating 2, 1 of the length equal to the one we have drawn the orthographic view. Then you close that side. That will be exactly 30 degrees. Now this is one end. And where will be the other end? So that will be equal to the height of the axis which is given as 70 mm. So from each of these points 1, 2, 3 and 4, I am going to draw horizontal edges. So imagine I am packing this hexagonal prism inside a rectangular box like the one we have in a toothpaste. So the toothpaste will be inside a rectangular box. Likewise, I'm going to draw the skeleton. So inside which we'll be having the actual view. So this has to be drawn extremely light. Now the other rectangular lamina will be at a distance of 70 mm which is indicated as the length of the axis. So from each of these points you draw lines inclined at 30 degrees of length 70 mm. Why inclined 30? Because all these are horizontal. It is resting on the plane on its rectangular face. So all these vertical edges will be parallel to the base. Vertical in the sense when we are keeping the solid vertical. In this case, it is lying on the ground. So all these edges will be horizontal. So they have to be drawn as third degree inclined lines. So I am drawing all points from this and then join the other end. So this will give you the skeleton. So I am naming the same same nomenclature. So this is actually the skeleton. So inside the skeleton, we are going to draw the actual view. So this has to be extremely light. So when you are finishing the answer, only the hexagon which we are going to draw inside should be highlighted. So that I'll draw in another color. So this should be extremely light when drawing. Now this is a very important step in this drawing. Now I've drawn the skeleton. Now I'm going to plot these points on this isometric projection. So this 1, 2, 3, 4 is exactly same as the 1, 2, 3, 4 dimensions shown in this orthographic view. Now you take a compass and you plot these values or take this distance, say from 3 to C, take the distance on a compass, and from 3 you mark that point. Similarly, from 2 you measure the distance till B. So in this isometric projection you mark the distance B from 2. Similarly, you take the compass, measure 2A, mark the point A from 2, and you can see that 2A, 3D, they will all be the same dimension. So if you are taking 2B, you can see that the 2B distance will be same as C3, E4 and 1F. And you have to draw on both these vertical laminas. So when you're taking this dimension, make sure you are completing all this around this in both the laminas. That will save you time. Okay, so likewise, I'm plotting the points C, B, A, F, E, D, and similarly the same points on the other end as well. Now the next step is to join them. So here you have to think about the visibility. So you're keeping the solid like this. So you have to identify which all edges will be visible and which all will be invisible. So all the visible edges should be drawn as continuous lines, and the other which are invisible should be drawn as dotted lines. So that's the next step. So when you're looking at the solid in this way, you can see that this face, this hexagonal face will be visible to you, and the edges on this side, on the right side, will be visible, whereas this face which is at the farther end will be totally invisible, and only the outer edges will be visible to you. Now I'm going to join all the visible edges. So this face, all the 6 edges will be visible, so I am joining them as continuous lines. And the edges, so these edges which are visible, I am joining it as continuous line, and on the other end also I am joining whichever is visible. So you should have an imagination of which all will be the visible and invisible edges. So if you are looking at the solid in this angle, these much number of edges will be visible, and all other edges will be invisible. So they have to be joined using dotted lines. That's the next step. Now I've joined all other edges using dotted lines. So this gives the figure. So if you're drawing an orthographic view, the dimension should be labeled as the actual dimension itself. So since you have drawn the orthographic view, you can show the dimension in the orthographic view itself. So the axis 70 can be shown in the isometric projection. So you can spread out the dimensions. So since here you are having the hexagon, you can label 30 over here and 70 over here. So while you are making this dimension, make sure that you are taking the projectors from here. So the dimension line should be parallel to this side. So wherever you are drawing the dimension, it should be parallel to that. Then you mark the scale on top, scale 1:1. So this completes the question.